Hey everyone, this is Miss Valentine, and you are watching the Air Pollution from Fossil Fuels Notes for AP Environmental Science. The pictures here on the first slide are of point source pollution, and you're going to read about this in your textbook, but point source pollution is when you have a point that you know it's coming from, a source that you know it is coming from. On the left is the stationary point source, so a factory, and then there's the mobile point source, which is you know it's coming from cars specifically. Now, there's also non-point source pollution where you don't know exactly where the pollution is coming from. And that's another thing that you're going to read about in your textbook. So we have major types of pollutions associated with the air. Air pollution, as a definition, is just chemicals that are in the atmosphere in quantities and for a duration that cause harm to humans. Or to other forms of life and materials in our world. So there's a lot of damage that can be done to plants and building structures. We'll talk about that a little bit later. But also, human health is obviously one of our most important focuses, at least for most of society. Primary pollutants are chemicals that are released into the atmosphere and they mix vertically and horizontally. So they get moved up and down, side to side in the troposphere. And that's another thing you're going to read about in your textbook about the different layers of the atmosphere. The troposphere is the bottom layer. So that's the layer that we are in. And it goes up quite a ways. The next one up would be the stratosphere. But the troposphere is where we exist on the surface. It's where planes fly. It's where most of what we consider uh, like the Earth's surface is located. So even Mount Everest doesn't even come close to reaching the top of the troposphere. So troposphere extends pretty far. It's where most of the gas molecules are located. And so it has a pressure effect on us. That's why we have air pressure here, a lot higher air pressure here. So that's primary pollutants. Secondary pollutants are primary pollutants that react with one another and they form new pollutants. So it's typically some of your primary pollutants get mixing with sunlight, especially, and then also water, two big chemical catalysts, if you will. So it causes the chemical reaction to happen, and that produces new pollutants that weren't directly released from a source on the ground. Here's showing some of the primary air pollutants that we're familiar with: carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxide. Notice oxygen in all of these. Hydrocarbons like fossil fuels, and then particulates, which we'll talk about what particulates are. Those go into the atmosphere and then they mix with sunlight and water often to create ammonium sulfate, sulfuric acid, ammonium nitrate, nitric acid, and then ozone, which is an important part of our stratosphere, the ozone layer, but it's really bad on the ground as a pollutant. Let's talk about some of the different types of pollution that we might see. Photochemical smog. So photo is light, chemical is chemical, obviously. So this is the chemicals that mix with light, and it creates this smog, the brown smog that we usually see on cities. It's a mixture of both primary and secondary pollutants under the influence of sunlight. Again, that photo part is indicating sunlight. Primary pollutants involved are mostly nitrous oxides and then volatile hydrocarbons. Again, the fossil fuels are a major source of those hydrocarbons. When you put sunlight with those, it produces ozone, aldehydes, PANs or nitrates. I don't even know how to say that word. And then nitric acid, which obviously we don't want acids in our atmosphere or even in our clouds. And that will actually end up becoming part of acid rain. Pause the video if you need a moment to finish up copying this slide. This picture is showing photochemical smog and what happens. The smog is released from a car, say, or it could be a power plant. And this is specifically on the coast with a mountain nearby. So this is what happens a lot in California. The sunlight will mix with the nitrous oxides, and then you add more oxygen, you may add sunlight and the heat, and it causes this haze to happen, which is a mix of all these different volatile organic compounds, sulfur dioxide, nitrous oxide. So you have new compounds resulting from things that are just coming out of your car. So just because it releases one compound, other ones can form when mixed with water and with sunlight. Here we are at our first pit stop. What is the difference between primary and secondary air pollutants? Pause the video while you answer the question. There are a lot of chemical reactions that you will write down in these notes presentation. Typically, when you see chemistry on the AP exam, it has to do with air pollution. So these formulas are important for you to know, but we'll definitely do some review right before the AP exam, since this is not something you typically will remember off the top of your head. But these chemical equations are very important for you to know. So mixing of nitrogen and oxygen gas forms nitrogen oxide. That's this 2NO. That then mixes with more oxygen in the atmosphere, and that creates nitrogen dioxide. And that is a yellowish brown gas with a choking odor. So that is something that we get a lot in cities and in the case of photochemical smog. Some of that nitrogen dioxide then reacts with water to produce nitric acid, which is this right here, and nitric oxide. So this chemical formula is just the first step. Then some of that nitrogen dioxide also mixes with UV radiation to create nitric oxide and just an extra oxygen gas, a free-floating oxygen. That free-floating oxygen will then combine with oxygen gas very quickly because it's not stable on its own, and that is what forms ozone. Now, ozone we've talked about in the past. It's actually a pollutant at ground level. So ground level ozone is really bad for us to be breathing in. It is good for the stratosphere. So when it gets all the way up to the stratosphere, it forms the ozone layer, which protects us from UV light. So it's an important blocker of UV light up in the stratosphere, but down at ground level, it's not good to have it there. It's also a greenhouse gas as well. So that's kind of important to know. Hydrocarbons, so again, fossil fuels, can mix with oxygen and nitrogen dioxide to create peroxynitrates. I wish I could say that word, or PANS, PANS for short. So those are just some of the initial chemical equations related to nitrous oxides, which again come from a lot of industrial processes and fossil fuel burning, like in cars and in factories. Industrial smog also contains sulfur dioxide, which eventually becomes sulfuric acid when it's mixed with water. And there's another great portion of that industrial smog that has particulates in it. So particles and droplets that come from coal or oil. So industrial smog has more of a gray color. So this is a little bit different than the brown smog that you often see in a city. This will take place a lot in areas where you have a lot of manufacturing or power plants. So here's the chemistry of industrial smog, or that gray smog. In the troposphere, again, the lower part of the atmosphere, some of the sulfur dioxide reacts with oxygen to form sulfur trioxide, which then reacts with water to make sulfuric acid. So this is acid rain. Acid rain also comes from the nitric acid that we talked about in the last type of pollution in the last couple slides. But acid rain, sulfuric acid is a major component of that as well. And here are the chemical formulas here. Again, you'll need to know sulfur dioxide mixing with oxygen to form sulfur trioxide. Then the sulfur trioxide mixes with water to make sulfuric acid. And so this acid rain here destroys vegetation often the most, and then it also destroys some of our human structures. Culturally significant, but not as damaging for the ecosystem as acid rain would be. Now, in the United States and other developed countries, they have reduced the amount of sulfur in the atmosphere, and that has reduced our acid rain. But in developing countries, they still have a lot of high sulfur coal that they use for energy, and so sulfuric acid rain is still a problem in developing countries. Now, one of the other reactions that takes place is that some of the sulfuric acid droplets react with ammonia in the atmosphere, and that forms solid particles of ammonium sulfate, or salts. And then if you mix the salts with the soot that comes from the power plant or burning of fossil fuels, it gives that characteristic gray color to the smog. So this is showing that reaction of the ammonia with the sulfuric acid, and that creates the gray, the ammonium sulfate salt. And that is a pollutant, of course, to humans as well as plants and other living things. All right, so here is a pit stop. Feel free to use chemical equations if you'd like, or if you just like to describe it in words. But how does sulfuric acid form from industrial smog? Pause the video while you answer the question. There are a number of factors that might influence the formation of smog. We in Ohio do not experience a whole lot of smog except for maybe in the summertime, but there are parts of the world that get it almost year round. This picture that I have posted up here is showing the mountains, a view from the mountains in California when you are up there and then the valley is down below. And this is what I used to see when I lived in Fresno, California. Fresno was in the valley, and then there was the Sierra Mountains up above. So even getting up into the foothills, you'd see this smog. It was like almost a pool of smog. And it's really disgusting looking, and you realize, oh my gosh, I'm living down in this most of the time. So topography makes a big difference in how well smog can form because it can trap the smog in that area. So local climate, we'll talk about thermal inversions, which is related to climate. Topography, the amount of industry in the area is important. And in the case of California's Central Valley, there's a lot of agriculture as well. So you have a lot of pesticides being sprayed, and that contributes to the pollution as well. So the amount of traffic can also make a difference as along with the industry. So transportation again can have an influence. Precipitation makes a huge difference because rain and snow will cleanse the atmosphere. It basically grabs a hold of those particles and brings them to the ground. In the summer in Fresno, when I lived there, there was no rain all summer. So it was pretty much just accumulating smog constantly. Whenever there was rain, it was like such a breath of fresh air. The wind patterns will also have an influence. And if you live in a valley, wind patterns tend to be a lot lighter than what we see here in Ohio. So in Ohio, the land is flat, and so the wind can just blow through here and wipe any pollution out of the way. So precipitation and wind allows us here in Ohio to have clean air most of the time. Hills and mountains will reduce the flow of air into the valleys, like I just said, and allow the pollutants to accumulate at ground level. I'll say when I did live out there, or before I lived out there and I would go out to visit friends, as soon as I'd step off the plane, and this was like usually in the summertime, I would feel like I had a cold, like within hours. I felt like I had gotten sick, but really all it was a reaction to all of the pollution that was in the air. So you get used to it when you live there, but if you come from this clean air in Ohio and go visit people in the Central Valley of California, you will feel the air pollution hit you. If you ever fly out to see Yosemite National Park, you guys all will fly into Fresno, so maybe you'll notice that difference in the air quality when you get out there. Another thing that influences formation of smog is temperature fluctuations, and they cause the pollutants to move up or down in the atmosphere as a result of density differences. And that prevents the pollutants from accumulating at ground level if you have that vertical movement of air. And we'll talk about thermal inversions in a few slides here. And that is when the vertical air is not able to move up and down, and so the pollutants just stay there at ground level. Thermal inversions are a problem in the Central Valley of California almost all year long, but there's other places as well. Again, it's usually when there's mountains around or hills around that kind of help trap the air and prevent it from mixing. Well, there we are, thermal inversions. So in normal cases, you have warm air rising up. And so that is the typical pattern we see anywhere in the world. If you go up higher elevations, you start to feel colder air. So this is a normal vertical mixing of air. In a thermal inversion, which is typically in a valley where the air can become trapped and doesn't circulate, you have a high pressure system that moves in. High pressure is usually associated with sunlight, so it's usually in the warmer months. The the sunlight helps contribute, or the high pressure system helps to contribute to this warm inversion layer, and that forms over the air below it, And it actually, since it is warmer, it acts as a cap. You have colder air on both sides of that inversion layer, and that prevents the air from mixing the way that it normally would. So what happens is the air circulates only at the ground level, and you're just mixing those pollution or that pollutant. So air does not get circulated the way that it normally would in normal conditions, in a non-thermal inversion conditions. And they typically only happen for a few hours, but in areas where there is sunlight constantly or a high pressure system gets stalled, it can happen for several days. I remember when I lived in California, it would happen all summer long. Again, the high pressure was there constantly. There were no clouds in the sky in the summertime where I lived. So you always had this high pressure system just trapping the air and no rain to bring the pollution down. It was just disgusting. So they have all sorts of lung problems out there. We'll talk about some of the health conditions that you see when there's lots of air pollution. But it definitely makes me very grateful to live where I do, where you can actually walk outside and breathe the air and not be negatively impacted by it. So Los Angeles, California is another location where you have mountains on all sides or almost all sides. It has an ocean, which actually does help wipe some of the smog away. Not enough, though, that they don't experience smog. So they have thermal inversions 50% of the year. Again, a big part of that just has to do with the high pressure conditions, the sunny skies. But they also have a lot of people. So 16 million people, 24 million motor vehicles. So it's subject to thermal inversions constantly. Um, LA has the worst air pollution in the USA. The second worst is actually one of the locations I lived when I was in the Fresno area. It was called Clovis, California, and they had the second worst air conditions in the world. I think they had more industry in their area. So, pretty awful air. You think of California as a beautiful, like nice weather place, but not always. Depends on where you are. Other highly polluted cities in the world, again, I talked about Fresno because that's where I used to live. Bakersfield is also in the Central Valley of California. Moving away from that, Denver, Colorado has lots of mountains, so that helps keep some of the air trapped in. Mexico City, Mexico, you can see a picture there. Rio de Janeiro and Sao Paulo, Brazil, those are both bigger cities as well. And then Beijing and Chiang, China, and Bangkok, Thailand. So here's a picture of Beijing. When they had the Beijing Olympics in 2008, they actually brought in huge fans to blow the pollution out of the city. And then I've heard of stories of in Beijing where they might have like a giant projection screen there, and they'll project a picture of the sunset because people can't see the sunset over all of the smog. Now, there has been a movement since then by the people in China to reduce their coal usage, to reduce the air pollution. And if you know anything about China, they're authoritarian. So having enough people amassed to make actual change in their air pollution laws is a pretty big deal. It means that everybody is affected by it and wants to see the change. So they have actually brought their pollution levels down, or have a goal of bringing their pollution levels down to some extent. Here we are at our next pit stop. Pause the video while you answer the question. Describe how a thermal inversion occurs. And you can use a shortened version of what I mentioned. And remember the high pressure system, the sunlight, and the role that that plays as well. That might help you answer the question. Let's take a look at the human respiratory system and how it is impacted by air pollution. So, just basic anatomy, our nasal passage has hairs in it that help filter out pollutions. And then when we sneeze or cough, we are expelling contaminated air. So, our body notices that there's something wrong or there's something amiss in the nasal cavity. And so you sneeze or you cough to get rid of that. Um, and then particulates in your lungs often will cause you to cough out as well. We have sticky mucus in our upper respiratory tract, and that helps capture some of the small particles and filter out some gaseous pollutants. So it depends on the concentration of the pollutants in the atmosphere as to whether or not your respiratory system can handle it. I don't know if any of you guys have been cleaning, or even like if you're out at a campfire and you like are exposed to a lot of smoke, like your snot will become black, and it's basically like from all the particulates that you're picking up while you're dusting or cleaning, or if you're outside like in a dirty situation. So you can actually see the dirt most of or when you're doing activities like that. Most of the time you don't see that. The cells of our upper respiratory tract are also lined with cilia that move back and forth. If you remember from biology class, the cilia are kind of attached and they're stationary. They have this flagella like cells on them, and they are transporting mucus and pollutants that are trapped in your throat. So, this is something that actually goes away if you're a smoker. So, smokers, it will oftentimes kill the cilia, the flagella that they use to push dirt out, and that causes smokers to have a lot more dirt buildup inside as well. So smokers need to be able to cough to get things out because those cilia are not just naturally lifting them out. Um, Alveoli in the bronchioles allow for proper gas exchange. So there are these little tiny bulbs at the end of your lungs, at the end of the bronchioles, that that's where the oxygen and the carbon dioxide cross over from the blood into the lungs. The oxygen passes into the blood, and then carbon dioxide passes out of the blood into the lungs, and you exhale it. So that's where gas exchange takes place. And we'll look at some pictures of the alveoli in a few slides. So, what does air pollution do to our health? It is very, it affects sensitive people most of all. And I know I keep mentioning California, but they had such bad air pollution. The notification system that they had in California was pretty regular, almost as part of your weather. It would tell you what the air condition was. And they would hang a flag at the school where I worked to indicate the air condition. Oftentimes it was set at air pollution or air conditions that were unhealthy for sensitive people. And if they got to the darkest level of red, like unhealthy for everybody, all the gym classes had to be inside. So it was interesting, like to monitor the air quality every day through a flag outside the school. Um, Air pollution can cause lung cancer. Usually it's associated with smoking, but it could be an industrial condition. If you work in an area that has a lot of industry, you can still develop lung cancer from that. So smoking is not the only way to get lung cancer. Asthma is acute, remember, short-term inflammation of the alveoli and bronchi. Usually an allergic reaction causes it to happen. But again, asthma can be a chronic condition. It's usually just acute inflammation, meaning short-term inflammation that reoccurs over and over again. And then chronic bronchitis is persistent inflammation. Chronic, again, is long term. So that's when you frequently have inflammation in your cells lining the bronchioles and the bronchi. That's these little branches here. So if that's constantly inflamed, that's chronic bronchitis. You end up with mucus buildup, painful coughing, and shortness of breath. And unfortunately, being a chronic condition, it doesn't go away. It often bothers you. All right, so here is our next pit stop. Pause the video. What is the difference between inflammation from asthma and inflammation from chronic bronchitis? All right, what are some of the other effects of air pollution on health? Emphysema is irreversible damage to the alveoli. So here's a picture of the alveoli in a normal lung versus one that has emphysema. And what it causes is abnormal dilation or expansion of the air spaces and a loss of lung elasticity. What that means is that people with emphysema cannot exhale very well. They can inhale air, but because they don't have that elasticity and they have that just wide open space, they have trouble exhaling. So if you ever are near somebody who has emphysema, you can hear them laboring when they're trying to force air out of their lungs. So that's the major part of emphysema. Carbon monoxide is a pollutant out in the open, but it's especially bad as an indoor air pollutant. And what it does is it reacts with the hemoglobin and red blood cells. It basically binds to the oxygen receptors on red blood cells and prevents oxygen from binding there. And that could be really bad if you have, say, an inside gas generator. A lot of people will use it during really cold periods. They don't realize that the gasoline powered generator is putting carbon monoxide in your home, and that can actually kill you. That's where carbon monoxide deaths come from each year. But it also can happen as a result of faulty gas furnaces, wood stove, kerosene heaters. So in general, you want to make sure that you don't have excess carbon monoxide inside. You now can buy carbon monoxide detectors to tell you when there's an elevated level. Typically, it will make you tired or give you a headache at first, but it can eventually kill you if you have so much of it in your system. Suspended particulate matter is basically just small particles. They're small enough to penetrate the lungs and get into cellular tissue. Mostly it's an issue for carcinogenic materials, but it can also irritate asthma and other lung diseases like bronchitis. So the particulate size is very, very tiny and it's measured in micrometers. So you'll see PM10 is 10 micrometers. A human hair is 50 to 70 micrometers, so it's much bigger than or much smaller than like the diameter of our human hair. So you cannot see these things that you're breathing in. But particulate matter is particularly potent in industrial pollution, and it can cause, like the slide says, cancer. Sulfur dioxide, again, causes acid rain, but it also constricts the airways. So it can cause constriction of the airways for people with asthma. And the World Health Organization estimates that 625 million people are exposed to sulfur dioxide, especially from burning fossil fuels, specifically mostly coal. Nitrogen oxides also contribute to acid rain, but they can also irritate the lungs and aggravate asthma and chronic bronchitis. There's also been recent research that has shown that nitrogen dioxide can also contribute to malignant melanoma, which is a type of skin cancer. So they're not just causing acid rain, they're also influencing or harming people's lungs as well. Volatile organic compounds or benzenes and formaldehyde are just an example. They are toxic particulates that can cause mutations, reproductive problems, and cancer. And these are also associated a lot with natural gas production and fracking. So, all of these things, volatile organic compounds, are really bad for people who are exposed to them. It's often people that are in close proximity to industry or, like I said, gas production. Ozone is a pollutant at ground level. So once again, I think I mentioned this already. Ozone is good in the stratosphere because it blocks UV light, but ozone is bad down at the ground level. It can cause coughing, chest pain, shortness of breath, eye, nose, and throat irritation. And you do see ozone alert days occasionally here in Columbus, and that's usually during the summer. It's generally when the air is thick and heavy. I think that helps trap the ozone somehow. But this is a picture of a news slide from Denver, Colorado, which also has a lot of air pollution. But this is a day that they have an ozone action day. They recommend that you don't fill up your gas tank or run gas powered lawnmowers during ozone action days because it increases the ozone concentration in the atmosphere. You might also see in places that have air pollution this sort of scale. This is actually what I saw when I was out in California. The flags that they would fly up on the flagpole outside the school were these colors. So basically, if it was in either of these flag colors, the gym classes had to stay inside that day. So we don't have that here because we have good wind and precipitation, but that does exist throughout the world. How many people actually die from air pollution? Well, it's not very well tracked. An estimate is that 65,000 to 200,000 annual deaths in the US are related to exposure to air pollution, especially to fine or ultrafine particulate matter. After 9/11, which this picture is showing here, we saw those numbers increase because there was a lot of particulate matter in the World Trade Center buildings that people were breathing in when they came down to work in that area. According to the American Lung Association, the US loses about $150 billion a year in the healthcare and work productivity costs associated with people with lung cancer, again, or with lung disease and air pollution. Again, these are estimates. We don't have great practical data tracking for this, but the World Health Organization and World Bank estimated that in China, which is one of the worst air qualities in the world, 1.2 million people die prematurely each year from the effects of outdoor air pollution. Now, since then, since 2010, there has been some regulation in China to reduce the amount of air pollution. So again, that has been a big plus, not only for our efforts to reduce climate change, but also for the people that live there to be able to breathe better. Here we are at our next pit stop. Describe two major effects of air pollution on human health. Pause the video while you answer the question. There are also harmful effects to materials in our immediate environment as a result of air pollution. There's fallout of soot and grit that gets on buildings and cars and clothing, especially in areas where there's a power plant or industrial production. Air pollutants can also break down exterior paint on cars, buildings, and then deteriorate roofing materials. So these things are not just harmful to our lungs; they're also harmful to all these different things that we use to live in and to survive. Um, there are irreplaceable marble statues from centuries ago and historic buildings that are deteriorated by this. Stained glass windows, which is what you see pictured there, have been discolored and broken down by air pollutants as well. So, although the health concerns are certainly the most important, there's also a lot of economic damage associated with the air pollution degrading materials. Pause the video if you need to continue copying this. To prevent significant deterioration in our health and in materials, the EPA, under the Clean Air Act, released national air. Oh, here I went too fast. There we go. Let's talk about preventing air pollution. So, Clean Air Acts of 1970, 77, and 1990. So, these are major laws that went into place through Congress. They require the EPA to establish national ambient air quality standards, or NAAQS, for certain outdoor pollutants. So you can see some of the major ones that we talked about here. Suspended particulate matter, sulfur oxides, carbon monoxide, nitrogen oxides, ozone, volatile organic compounds, and lead. So I actually have all of these listed here in this graph, and it shows how since 1990, the latest reboot of the Clean Air Act, how these things have come down. And you can see the Clean Air Act of 1990 was mostly geared towards these ones that have since fallen. So regulation is needed to control air pollution if you don't want to be more like a developing country and experience the associated health concerns related to that. So, steady since since the 1970s legislation are ammonia. Let's see, this is direct particulate matter, less than 10 micrometers, micrometers, and then the particulate matter less than 2.5. So we've been regulating the particulate matter for a while. I think that's because it has the biggest effect, and then ammonia as well. These other ones are more recent: carbon monoxide, sulfur dioxide, volatile organic compounds. But you can see as we put in legislation, the levels drop. One that you don't see here is actually carbon dioxide, which we are now trying to regulate more because of climate change. Back to this slide. So, under the Clean Air Act, the EPA has established certain standards, but that doesn't mean that they should let the air quality deteriorate to those standards. We've got to make sure we keep our air clean as possible. The National Emission Standards for Toxic Air Pollutants has 302 different compounds and 20 categories of chemical compounds that are harmful to human health. But there's not a lot of money put into setting standards and enforcing standards for those compounds. So only a few have been set and are enforced by the Environmental Protection Agency. And truly, the enforcement effort completely depends on funding for the Environmental Protection Agency, which varies based on what president you have in office. So the EPA is required to set standards, but they aren't necessarily required to enforce standards unless there's a person in office that believes that that is an important priority. Car emission tests are common in places like California. This is a picture of a California smog check location. When I lived there, you had to get a smog test on your car every 2 years. It was like $50. When you go in to get your oil change, you'd get your car smogged. I got this cool picture of this guy here pointing to the emissions test location there. But the only county in Ohio that does that is Summit County, which is up closer to Cleveland. But California is very progressive when it comes to air pollution because they experience air pollution so much throughout the year. So basically, if you fail an emission test, you have to have a new catalytic converter put in, and that will reduce the amount of pollution. We also have started adding ethanol to our gasoline. So automotive gasoline has to have at least 10% ethanol in it in certain cities. So this is to help reduce pollution there. You can see this picture here. You might have seen like E85, but I found a picture of E15 ethanol, which has 15% of ethanol. Ethanol, it can be created from any type of biomass or plant, but we in the US use mostly corn. So we grow corn and then turn that into fuel that can be mixed with our gasoline and reduce the amount of emissions. Presently, we've had decreases in the atmosphere of ground ozone, carbon monoxide, sulfur dioxide, suspended particulate matter, nitrogen dioxide, and lead. So all of the materials that were listed on that former slide, except for volatile organic compounds. So that one we have seen some decrease, but the biggest ones, the major ones you see there, are those compounds. I'm saying that wrong. All right, so I just mentioned it, but which atmospheric pollutant, if you look at the list that we took a few slides back, which one is not listed as declining since the 1970s? Pause the video while you answer the question. So, how can we improve our air pollution laws? Pollution prevention is the best method. You don't. It's very difficult to take the air back out, or the pollution back out of the air once you have it in there. So, lead and gasoline was outlawed. And it took no time at all for the lead to be reduced by 98% within a few decades. Now, they still use leaded gasoline, I believe, in race cars. But so don't live near a racetrack if you can avoid it. Um, Increasing fuel efficiency standards for cars and trucks, that's actually a huge push in the Biden administration, is to increase fuel efficiency. To find the fuel efficiency, when you go to buy a car, you see a label somewhat like this, and the fuel efficiency is in miles per gallon. This is kind of a cool scale I haven't seen because I haven't shopped for a car lately, but how the vehicle compares to other ones. And I noticed like the best case scenario is 103 miles per gallon. If you guys know what car has 103 miles per gallon, let me know because that's got to be really good. It also has an impact of greenhouse gases and outdoor air pollution on it too. So you can actually compare to other types of cars that are out there if you know what they are. So we could require stricter emission standards. We could do smogging in locations around the country, not just in certain states and counties. We could fund research and development for alternative energy sources. And I think that's another huge push of the Biden administration. And then subsidize businesses and homeowners that use energy conservation, hybrid vehicles, and solar and wind energy. So right now, there's like a tax deduction for getting solar panels on your roof on the home. I think it's like $7,000 deduction or credit or something on your taxes. So we do have some incentives. So the more incentives you provide for homeowners and for businesses to implement alternative energy, the more those technologies are going to be used. And again, that just again depends on who's in power in Congress and in the White House. What can you do personally? Carpool if you can, or use mass transit, use the bus system. Turn off your lights. Anything that you do to reduce energy. So, the Energy Star program, conserve water and electricity when you can, and then refuse, reduce, reuse, recycle. So, the four R's, refuse would be don't take that plastic bag at the store, or it's usually that's the one I can think of, the one example I can think of. And then use alternative transportation. If you can walk to a location, walk there. It's good for your health too, as well. So, all of the things that we've been talking about when it comes to energy and reducing your energy use, that is the biggest thing that you can do to reduce air pollution as well, since the two are linked. All right, here we are at the summary. Read through your notes again and write a 10-sentence summary about air pollution from fossil fuels.